هلأ رح نحل دورة 2017 العادية بدرس الكومبلكس نمبرز. عنا complex plane بقلبه point A الأفكس لإلها I. إذا بدي أكتبها على شكل image الريل بارت لإلها 0 والimaginary بارت إلها 1. coordinates معروفين فهن للبوينت A. فينا نقول إنه البوينت A هي fixed point. إن point B الأفكس لإلها minus 2I. إذا بدي أكتبها كمان على شكل image حط الريل بارت اللي هو 0 والimaginary بارت اللي هو minus 2. coordinates معروفين. the point B is a fixed point. point M مش معروف شو الأفكس تاعولها ففينا نكتب بالalgebraic form x plus iy. إذا بدي أكتبها على شكل image الcoordinates لإلها هني x و y. coordinates are unknown, so we can say that M is a variable point. وعندنا point M prime الأفكس تاعولها z prime فيني اكتبها in algebraic form واكتبها على شكل image real part followed by imaginary part. coordinates are unknown, so we can say that M prime is a variable point. أعطيني relation between z prime and z. هيدي ممكن تكون الكي للحل بكتير parts عنا بهيدا السؤال. لهلا عندي 2 points، اثنين منهم fixed واثنين منهم variable. First part, prove that z prime plus 2i z minus I is a real number. شفت z و z prime مع بعض، أول شغلة بدي أخدها هي relation اللي بيناتهم لأنه هي رح تكون أساس الحل. I'm going now to find or to calculate z prime plus 2i multiplied by z minus I. Using the given relation, we replace z prime by minus 2iz divided by z minus I. In order to add two fractions, we have to take a common denominator. Multiplying here by z minus I and multiplying the numerator by z minus I, now we have to expand by multiplying 2i by the brackets. Use the fact that I squared is always equal to minus 1 minus 2iz and plus 2iz cancel each other. I squared is equal to negative 1. Negative 2 multiplied by negative 1 gives a plus 2. Cancelling z minus I and z minus I with each other, the result will be equal to plus 2. The answer is a positive real number. Verified. Deduce that AM times BM prime equal to. هون بدي أتذكر الموديولس بما أنه عم يحكي لنا عن distance عن magnitude. AM by definition هي modulus ZM minus ZA. BM prime ZM prime minus ZB. Z للM according to the given هي Z والZ للA هي I. Z للM prime هي Z prime والZ للB هي minus 2I فبتصير plus 2I. ما جبت شي من عندي، هذا كلياته ذكرنا ببداية السؤال كلهم given عنا. هلأ من شوي صغيرة كنا بعدنا مبرهنين إنه z minus I times z prime plus 2i equal to ببارت 1a. إذا لاحظتوا نفس الشيء z minus I z prime plus 2i، بس الفرق عندي فكرة الموديولس. أنا رح دخل الموديولس وموديولس. Modulus of 2 is equal to. So we can say that am times bm prime is equal to. Given that m is moving on a circle of center A and radius 3. So suppose we are in a circle, center لإلها A, m is moving on the circle, am is equal to 3 centimeter. Because radius is equal to 3, so we can conclude that am is equal to 3. We have to show that m prime is moving on a circle of center and radius to be determined. كنا عم نحكي عن الام، صرنا عم نحكي عن الام prime، so بدي اتذكر الz with z prime أو any relation that relates m and m prime. In part 1b, we already verified that am times bm prime equal to. am is equal to 3, so we can say that bm prime is equal to divided by 3. من بداية السؤال إن b is a fixed point, m prime is a variable point. So b مطرحها ثابت، m prime مطرحها متغير. بس كيف ما تغير مطرح الام برايم عم تبقى الديستانس constant. نتخيل الشكل سوا. point B fixed يعني مكانها هون خلص مطرحها ما بيتغير. m prime is variable فيني حطها مطرح ما بدي، بس عشرة distance between B and m prime is always equal to over 3. ممكن نحط m prime بأي مطرح، بس whatever المطرح اللي نقينا m prime constant distance bm prime is equal to over 3. So we can say that m prime is moving on a circle of center B and radius 2 over 3. Given that z prime is equal to I, we have to write z in exponential form. Z and z prime, we have to use the relation that occurs between them. Given that z prime is equal to I, we have to find the value of z. I can simplify 2i by 2i. Let's now make a cross multiplication. Separating z. We get that 2z equal I, z equal half I. نحن طلعنا z، بس إذا لاحظتوا طلعتها in algebraic form. But it is required to write z in exponential form. So I have to convert z from algebraic form into exponential form. بس لأقول exponential form يعني I have to write it in the following form: z equal r ei theta. Since z is positive, pure imaginary, no real part here, look carefully, z, so it is positive, pure imaginary, so we can say that the argument is equal to plus pi over 2. Argument means theta. What about r? R is a modulus. Its rule is radical x squared plus y squared. X means the real parts, and here there exists no real parts, so x squared is equal to 0 squared. Y is the imaginary part, half square gives 1 over 4. So we can say that r is equal to half. Now replace r by half and theta by pi over 2, z is now written in exponential form. Given that z is equal to x plus iy and z prime is equal to x prime plus iy prime, we have to solve the following two relations. Again, z and z prime are in the same part, so we have to use the relation that exists between z and z prime. We replace z prime by x prime plus iy prime, and we replace z by x plus iy. Again, I'm going to expand by multiplying minus 2i by the whole brackets. Don't forget that I squared is always equal to minus 1. And from here, I took I as a common denominator. In order to divide two complex numbers, we need to multiply by the conjugate. Conjugate يعني I have to switch the sign of the imaginary parts. So replacing plus I by minus I. In order to multiply these two fractions, we multiply numerators by each other and denominators by each other. Expand by multiplying minus 2ix by the whole brackets and plus 2I by the whole brackets. And always remember that I square is always equal to minus 1. Expanding the denominators, they represent a case of difference between two squares. Remember that a plus b multiplied by a minus b is equal to a square minus b squared. Using all of these facts, you can get that x prime plus iy prime is in the following form. Again, I'm going to expand. And now it is time to reduce these terms. Minus 2xy and plus 2xy will cancel. Next step is separation, the real parts together and the imaginary parts together. Here is a collection of imaginary parts, so I'm going to take I as a common factor. Real parts from the left-hand side is x prime is equal to the real parts from the right-hand side, which is equal to x divided by x squared plus y minus 1 all squared. And imaginary parts from the left-hand side is equal to the imaginary parts from the right-hand side. Look carefully at y prime. I can take minus 2 as a common factor from the numerator, and the result will be in the following form. Given that AM is equal to radical 2, based on this given, I have to show that x prime is equal to x. AM is equal to radical 2. It's about modulus or distance between 2 points. So look carefully at the following given and know how to use it in a way that helps to prove that x prime is equal to x. AM is equal to radical 2. This means the distance between points A and M is equal to radical 2. Apply the rule of the distance between 2 points. من بداية الجيفن كانت الcoordinates للpoints XY والcoordinates للpoints A 0 1. So I'm going to replace XM by X, XA by 0, YM by Y, YA by YA by 1. X minus 0 is equal to X, Y minus 1, all square equal radical 2. So eliminate the radical, let's square both sides. So I'm going to square the left-hand side and to square the right-hand side. Square and radical cancel. Square and radical cancel. We can say that x squared plus y minus 1 all square is equal to. It is concluded from am equal radical 2. So أنا من am equal radical 2 قدرت أوصل إنه x square plus y minus 1 all square equal to. How to use the following relation in order to prove that x prime is equal to x. From the preceding part, x prime is equal to the following quantity. Look carefully. X squared plus y minus 1 all squared, it is equal to. So replace the following quantity by 2. Cancelling 2 by 2, we get that x prime is equal to x.